Okay, welcome back. We are now going to take a look at a couple more rules that will make figuring out derivatives a little bit simpler. So the first couple are pretty straightforward. The last one is also pretty straightforward, but it just allows us to work with more functions that are a little bit more complex. So first of all, let's take a look at our first rule. And we're also going to take a little bit of a graphical look at it as well. This is called the constant rule. Now, let me present my screen so you can see what I am talking about. And let me share this. So what we're going to take a look at is now called the constant rule. And what does that really look like? Well, if I give you a constant, so let's say a function actually is a constant, like f of x equals 8. What do you do to find the derivative of that? Well, I think the easiest way to understand this is to look at what the graph of f of x equals 8 is. If you remember, f of x equals 8 is a horizontal line that goes through y equals 8. Now, remember, if I ask you to take the derivative of that, the derivative is the slope at any point on that line. So if I went to here and I go up to this point, notice the slope of a horizontal line, of course, is 0. Any place I go on that line, the slope is going to be 0. So our rule that we have is the derivative of any constant then equals 0. So that was a pretty straightforward rule to understand. Okay, so the derivative of any constant is 0. Now, number 2, the second rule that we're going to take a look at is called the constant multiple rule. Now, this rule is kind of a combination of the power rule and a little twist kind of on that. So here's what it kind of looks like. So first of all, I'm going to show you an example. So let's say I give you y equals 5x to the 4th. Notice we have this right here. This we can do the power rule on. Okay? But we also have this right here. We have a constant that is being multiplied. So what do you do with that? So here's how the rule works. You take your exponent and you multiply it by the 5, or the constant that is in front. So the first thing we're going to do is we're going to do 4 times 5. Okay? And then we're going to finish out the power part. The power rule basically says you take the exponent and subtract 1. So we're going to have 4 minus 1. So what is our final derivative? Well, it's going to be 20x to the 3rd. So y prime equals 20x to the 3rd. And that is how the power rule works. Okay, so what does that look like in terms of just a generic formula? So let's say I give you d over dx, and then I give you bx to the n. What are you going to do with that? Well, what it says is you take the b and multiply it times the exponent, and then we have the same part of the power rule, x to the n minus 1. Now, sometimes it isn't as clear that you're using the constant multiple rule. So let me give you an example that might not look like the constant multiple rule, but it actually is. So let's say I give you f of x equals 4/5 over x to the 3rd. Okay, so it's 4 over 5x to the 3rd. I want you to find f prime of x. Well, what do you do with this one? So let's take a look at kind of how we have to morph this to use the rules that we do have. So first thing you should notice is that the power rule doesn't work when the x to the third is in the denominator of a fraction. So we need to move that up. So the first thing we're going to do is we're going to do 4/5, but we're going to move the x to the third up. Remember, anytime you move something with an exponent, you just change the sign. So if it's positive down there, it's going to be negative in the numerator. Now, the second thing you do need to recognize is this. You do need to recognize that this 4/5 is a constant being multiplied by that exponent. So what can we do? We can treat this as 4/5 x to the negative third. We can basically pull that constant out to the front and now use the constant multiple rule. So what do? I do -3 times 4/5. So I'm going to do that work kind of right over here on the side. So I'm going to do -3 times 4/5. And remember, when you're multiplying fractions, you just multiply across. So it's going to be -12 over 5. So I'm going to write that here. We have -12/5. And then I also need to do the power portion. So I need to do x -3 minus 1. So what is my final answer? Well, I have -12/5 x to the -4th. Now, sometimes that will be an acceptable answer. Sometimes AP will want you to put it in its complete form. So if it's in its complete form, you're going to have -12. You're going to have 5, and you have to move the negative back down to the bottom of the fraction. So it would be x to the 4th. Okay? So this is the constant multiple rule. Sometimes you need to morph the expression to make sure that you have both a constant and you have something to a power. Now, the final rule that we're going to be taking a look at is called the sum and difference rule. So the sum difference rule. And we all know that a sum just means to add and a difference means to subtract. So I like to show this rule just by showing you an example that you have probably seen. You have seen some sorts of polynomial expressions before. So let's say I give you y equals x cubed plus 4x squared minus 2x plus 7. Now, this rule is going to kind of apply a bunch of different things, but I just want to show you how you do the sum and difference rule. How I consider this is I just consider it, the sum and difference rule splits it up into parts. So this is one part, split by a plus sign. This is another part. So you'll notice this plus sign splits it into this minus sign, and this plus sign split everything into different parts. And what you do is the sum and difference rule allows you to take the derivative of each part. So let's take a look at this one. Let's just look at the first part. X to the third, we apply the power rule. So we move the 3 to the front, x, and then you have to do 3 minus 1, which is 2. So the first part of this derivative is 3x squared. Now, move on to the second part. This second part applies the constant multiple rule. So what that means is we take this and we multiply it times the constant in front. So 2 times 4 is 8. But remember, you need to subtract 1 from the exponent, so it's going to be x to the first. You do not need to write x to the first. You can just leave it as 8x. Now, the next part, remember, this is x to the first. So it's 2x to the first power. You have to apply the constant multiple rule. So 2 times 1 is 2. So it'll still stay -2. But remember, 1 minus 1 is 0. Anything to the 0 power, you do need to remember, anything to the 0 power is equal to 1. So what is 2 times 1? It's 2. Go to the last part. Plus, what is the derivative of a constant? Anytime you have a constant number, the derivative of any constant is 0. So here's kind of the thing. We don't need to write this in there. You can just keep that part off. So what is the derivative of this? The derivative of x to the third plus 4x squared minus 2x to the first plus 7. It's 3x squared plus 8x minus 2. Now, I just want to show you one example that uses a whole bunch of these rules and allows you to see how we apply them in a very interesting sort of situation. So I'm going to give you this expression, f of x equals 3 over negative 2x in parentheses to the fourth power minus x over 2 plus 1/4. Okay, so you look at this expression, you might think, okay, what do I do with all of this? Well, the first thing that you do have to take care of is you do have to take care of these parentheses. We can't work with a set of parentheses. Well, we can when we have rules later on that we can apply to them, but it's a lot easier. If you can get rid of the parentheses, get rid of the parentheses. So if you remember with exponents, you have to make sure that you use the exponent on both of these things. So what is negative 2 to the fourth power? So negative 2 times negative 2 is 4. Times negative 2 is negative 8. Times negative 2 again is positive 16. So this part is 16. Also note that we now have x to the fourth. So it's going to be x to the fourth, and it's all over or underneath 3. So we have 3 over 16 x to the fourth. Notice what I'm doing is I'm just focusing on this part to calculate the derivative of the whole thing because it is all being added and subtracted. So I can just work with each piece and kind of go through. So the second thing is, notice right here, you have x to the fourth, but you can't have the power in the denominator. So we do need to move that up. So that's going to change this to 3x to the negative fourth over 16. Well, there's one other thing you need to recognize. This 3/16, this is the constant being multiplied by the power. So if you need to, you can think of it as this, okay? You can pull the 3/16 out, and remember, it's 3/16 times x to the negative fourth. Now, let's apply the power rule, or the constant multiple rule. So we have to take this and multiply it times 3 over 16. So over to the side, I'm going to do negative 4 times 3 over 16. Do some kind of cross canceling out here. So this is 1 and this is 4. So we end up with negative 3/4. So for f prime of x, I get negative 3/4. And remember, I need to subtract 1 from that exponent. So negative 4 minus 1 is negative 5. Okay? So working just with this part, the derivative of that part is negative 3/4 x to the negative fifth. Okay, now let's work with this part. You need to recognize that this is 1/2 times x. So if you don't recognize that, you need to see it. If you need to pull it out to the front, you just notice this is 1/2 x. And remember, it's also implied to the first power. So let's apply the constant multiple rule. 1/2 times 1 is 1/2. And then remember, anything, you have to subtract 1 there. So x to the 0 is 1. So 1/2 times 1 is 1/2. So we subtract 1/2. Now, the final thing is this. Look at this part. You need to see that this is a constant. Even though it's a fraction, it's still a constant. So anytime you take the derivative of a constant, the derivative is plus 0. We do not need to write this plus 0 here. So what is your final answer? Your final derivative is this. Now remember, you could also move the x to the minus 5 to the bottom of the fraction, but I'm just going to leave it like that for now. Just remember that that might be a possibility. So this is the three other rules that we need to finish calculating derivatives quickly. I hope this helps, and I have just a couple more shortcuts and rules to show you, and then we will be set with derivative calculations.